Try not to swear too much, Jocelyn. Will we stop for the day? Okay. All right. So here we go. Today is 8/28.
How much do you weigh? Look at the guy.
Kind of a private conversation, don't you think? Didn't you ask him yesterday how much he makes on his last paycheck? And today is how much do you weigh? You just thinking every day? What's a weird question I can ask him?
Was it like 220 last time?
What's your social security number? What's the color of your underwear right now?
Yeah.
All right.
Green. Oh.
I don't want to know.
From the mold or?
Army green.
All right. We're recording. Back to this.
That is true.
Okay. So, data is info from observations, counts, measurements, and responses. Everybody read my handwriting?
Yes.
Okay. Riley, tell me an observation that you see right now. Just a fact that you can see with your eyes.
Are you wearing glasses?
I'm wearing glasses. That's an observation, and that is actually a statistic because we could figure out details about me, anything like that. What's a count? Counting. So, like, that would be, like, especially in, like, sports, like, how many touchdowns or whatever, you know, like, what?
You have 2 earrings.
I do have 2 earrings. That's a count. Great. How about a measurement? Sure. How tall I am? How much I weigh? None of your business, Riley. And responses? Responses are like if you give a survey, like what somebody responds. Okay? Statistics is a science of collecting, organizing, analyzing, and interpreting data. Collecting data either by observing or by counting or measuring or giving a survey. Organizing means putting it into a graph, something that's easy to read. Analyzing, did I spell that right? Analyzing, there's a Y in there. Analyzing. Analyzing data is like figuring out the mean, the median, the mode, probabilities, that kind of stuff. And interpreting the data is using the data to make decisions. Analyzing. A population is a collection of all info that matters to your study. Where a sample is part of that population. So let's say, for example, and remember when you can always write down things I'm saying and not just the things I'm writing, right? So if I was like, what's the average age of people in Lewiston? I'm probably not going to ask every single person in Lewiston how old you are. I'm going to take a sample. Maybe I'll grab like 100 people out of Lewiston. I'll ask them their ages. So that like collection of 100 ages, that's my sample. But the population would be all the ages of everybody in Lewiston. Example 1 says the U.S. Department of Energy conducts weekly surveys of approximately 800 gasoline stations to determine the average price of regular gasoline. On December 10th, 2012, this is real stats, the average price was $3.35 per gallon. What's the price right now? Oh, look at that. We're down.
Was yesterday.
Identify the population and the sample. Okay, so the population is all gas prices. You got to be as specific as you can. Of regular gasoline. But the sample is the prices of the 800 stations they observed. A lot of people think that a sample in a population has to be people. Like the people are what the sample is, the population is what the sample is, but it's actually the data. So imagine like a group of numbers, like all the gas prices in the world. Imagine all these numbers floating in front of you, but then the 800 that we look at, that's our sample. So it's just the numbers or the data that we care about. A parameter is a numerical description of a population. And a statistic is a numerical description of a sample. Example 2 says a company with 65 employees spent a total of $5,150,694 on employees' salaries. Does the amount spent describe a population parameter or a sample statistic? So here's the number. That's the numerical part. Is that including everybody, or is it not including everybody? Everyone. So this is a parameter. Descriptive statistics is the branch of stats that is all about organizing and displaying data. Where inferential statistics is the branch of stats that's about drawing conclusions. So descriptive means that this is facts. But inferential is more of an educated opinion. So, for example, let's say with the last presidential race, I looked at Lewiston and I said, it looks like 75% of Lewiston is going to vote for Donald Trump. Okay? That's just when I went and interviewed everybody. 75% of people said they were voting for Donald Trump. That's not my opinion. That's just what happened, right? That's just facts. That's descriptive. But then if I say, I think, therefore, in the election, because that's who they said they're going to vote for, so I think that Donald Trump will win in Lewiston. That would be an opinion because I'm guessing, right? It's not necessarily true. People could change their mind, or maybe I had a bad sample. But it is an opinion. But the facts can't be disputed. That's just what it is. Second page. All right, a survey of 750 parents found that 31% support their kids financially until they graduate college. And 6%, by the way, every stat I give in this class is true. 6% provide financial support until they start college. Determine which part of the survey represents the descriptive branch of statistics and what conclusions might be drawn. All right, so the descriptive stuff is this. This is descriptive. And this is descriptive. Thank you. That's facts. That's just the math. And if they're looking for a conclusion, I would say 31% of all parents will support their kids financially until they graduate college. Is it true? Is it definitely true that 31% of all parents will support their kids financially until they go to college? Or until they're done with college? No. But according to my sample, it's true. Therefore, I'm going to make a conclusion about the population. That is true. It's a guess, though. Qualitative data. That was all of 1.1. Now we're on 1.2. Qualitative data is attributes, labels, or non-numerical things. Lincoln, tell me something about me that is not a number. I have brown hair. That is an attribute of me. Okay? A label. I'm a teacher. My name's Laura. These are all qualitative data. They're qualities, which helps. Quantitative data is about quantities. They are numbers that mean something. So this is a measurement or a count. Is it possible to have a number that is more of a label than meaning something? Like what? Like the one you're wearing right now. So a football jersey number, that's a great example of something that's qualitative. Because it's just essentially like your name, right? Number 45, that's Tristan. Number 52, that's Riley. Number 11, that's Lincoln. It doesn't mean that you're 11th on the team as far as height or speed or how many hamburgers you can eat. It's just, yeah, it's just, what it is. Having a good time picking taffy off your hands now? Yeah. Okay. The population of several U.S. cities are listed below. Which data is qualitative and which is quantitative? So what do you think? Come on, you guys got to talk to me.
The cities are qualitative.
Yes, the cities are qualitative. These are a name of a city.
And then population
Quantitative, yep. These are quantitative. It's a number that means something. It's not a label. If I said, what's the population of Miami, Florida, I wouldn't be like, 408,750, and they'd be like, oh, that's how many people are there, and I go, no, it's just a number I like. Like, it's definitely, it means that's how many people are there. Then there are 4 levels of measurement, which is what you're remembering the flow chart from. Nominal is, this is only qualitative. This is names or labels. Or qualities, I guess, like I have brown hair. Ordinal levels of measurement could be qualitative or quantitative. These can be put in order. But the differences, and by difference I mean subtraction, is unknown. How's my speed? Am I going too fast? You're not overwhelmed yet? Yeah? That's a great point. All right, so if I said we're going to run a race, and Tristan came in first, and Riley came in second, and Jocelyn came in third, and Lincoln came in fourth. Okay? Do I know if it was like Tristan and then immediately Riley, or could it have been Tristan and 5 minutes later Riley crossed the line? I don't know the difference between first and second place. I just know who came in first, who came in second, who came in third. So I can put them in order, but I can't really tell you what the difference is between them. I don't know if it was like a really fast or if it was much wider. That kind of thing. And alphabetical doesn't count. So if you're like, oh, well, you can put any words in order, yeah, but not with meaning, right? It's just because A comes before B. That's doesn't count, not order. Okay, interval level of measurement is only quantitative. And this one, 0 is a position on a scale. A good example of that one is like temperature. If it's 0 degrees outside, it doesn't mean that there's no temperature outside. It means that it's just between 1 degree and -1. So usually you can go above and below 0 when it's interval. Time also is usually in this category. Like, what if I said it's 0-100 hours right now? What do I mean? Midnight. It doesn't mean time has ceased to exist. It means that it's right between 11:59 and 12:01. Okay, the last one is called ratio. This one is also quantitative, but on this one, 0 means none. For example, how many dogs do you have at your house right now, Lincoln? 2. How many dogs do you have at your house right now? How many dogs do you have at your house right now? 2. How many dogs do you have at your house? I've got 1. How many dogs do you have at your house? 1. Oh, darn it, we all have dogs. How many cats do you have at your house? 0. And that means none. That doesn't mean that it's part way between 1 cat and -1 cats. It's just there's no cats. Okay? So 0 means none. This is kind of like that flow chart I gave you where you can go through, can you put data into categories? Can you arrange the data in order? Nominal, you can't. Everything else you can. Can you subtract data values? That's where I was talking about the differences matter. So that's no, no, yes, yes. And then ratio also, it's something called the twice test. That means that I can have twice as many of something as you can. So if I have 4 cats at my house and you have 2 cats at your house, I've got twice as many cats. But if it's 4 degrees outside compared to 2 degrees outside, that's not twice the temperature. They're just positions on a scale, right? Okay, here are some good examples. So we're going to show you here some examples. Nominal. TV shows. Do you see how like comedy, drama, reality shows, sports, documentaries, cooking, soap operas, and talk shows, these are in alphabetical order, or they can be. But is there any order to them? Does comedy always go first? No. Okay. Here, ordinal level. Look at this one. This one now is ratings for movies. G, PG, PG-13, R, NC-17. Do you see why those are in that order? It goes from like the most mild movie you could show a kid to like NC-17, where no one under 17 is allowed to see it, even if they're with a parent. Okay? This one, interval, this is temperatures, right? Negative goes below 0. And then here, this is monthly precipitation. That's how much rain you're getting. One place could have twice as much rain as somewhere else. Okay, back page. I want you to sit with your Post-it partner, please. And you're going to label these 4 things with either nominal, ordinal, ratio, or interval. So go sit by your partner and try to label them. And if you're panicking because there's a homework assignment on the bottom, I'm going to give you time tomorrow to work on it.
Yeah, we need to turn that on.
Quiz on you today, yep.